In this video, we will discuss about the solution of second order linear homogeneous differential equation with constant coefficients okay. So here we will discuss the solution of second order linear homogeneous differential equation with constant coefficients. In the previous video we have discussed about second order linear homogeneous differential equation. What is a second order linear homogeneous differential equation? A differential equation of this form: second derivative of a function plus p into first derivative of the function plus q times the function equal to 0. Equation of this type, this is called second order linear homogeneous differential equation. Okay, here the coefficients are not constants. Here p and q, they are differential coefficients. I have told you, they are differential coefficients, and p and q are functions of which variable? Independent variable x. P and q are called differential coefficients, they are not constants, and they are functions of independent variable. If you have not gone through this equation, you watch my previous video, that is second order linear homogeneous differential equation. But here we will discuss second order linear homogeneous differential equation with constant coefficients. For constant coefficients, the differential coefficients p and q, they will be constant. So the equation will be second derivative of the function plus a constant first derivative of the function plus another constant multiplied by the function equal to 0. Okay. So this is your differential equation, that is second order linear homogeneous because of this side RHS side equal to 0, differential equation with constant coefficients because a and b, they are constants. Why we read this differential equation? Because this type of differential equation are very useful in mechanical vibration and electrical vibration. When you read different wave equations in mechanical vibration and electrical vibration in physics, the equation of the wave will be like this. That is the second order linear homogeneous differential equation with constant coefficients. So this is very useful in physics. So in this video we will find out the solution of this second order differential equation. Okay, what do you mean by solution? I have told you in the previous video, I have told you, if you have a differential equation, then solution means you have to find out the integration. We have to find out the integration, or called the integrand value. I have told you solution means we have to find out the integration of this solution. So when you find out the integration of any differentiation, then what will be the result? The result will be in the form of a function. So here suppose the solution of this equation or integration of this equation is of the form y equal to e to the power lambda x. Okay. Suppose the solution of this equation is of the form y equal to e to the power lambda x. Here lambda is equal to constant. So if you can find out the value of lambda, then you can find out the solution of this equation. Suppose you take this is equation number 1 and this is equation number 2. To find out the solution, what you have to do? You have to compute the value of y here. Then you find out the value of the first derivative of y with respect to x. Then you calculate the second derivative of y with respect to x. You substitute here. Then you will get the result. So what will be the first derivative of the function dy by dx? That will be equal to lambda e to the power lambda x. Is not it? Suppose this is equation number 3. And what will be the second derivative? The second derivative of the function will be equal to lambda square into e to the power lambda x. Okay, suppose this is equation number 4. Now what we will do? You have to compute, you have to substitute the value of y, the value of first derivative of y with respect to x, and the value of the second derivative of y with respect to x in this equation. So putting the value of 2, 3 and 4 in equation 1, what you will get? For second derivative, you write how much? Lambda square e to the power lambda x plus for the first derivative a into lambda into e to the power lambda x and plus b into for y you will write how much from equation 2. Okay, e to the power lambda x. So this will be equal to 0. So now you can take common how much? E to the power lambda x. So in the bracket you have lambda square plus a lambda plus b, this will be equal to 0. So you see here you have two factor. One is your e to the power lambda x. This may be equal to 0 and this may be equal to 0. You have two factor. Is not it? Two factors. But you cannot take e to the power lambda x equal to 0 because you have taken y equal to e to the power lambda x. So which one will be equal to 0? Lambda square plus a lambda plus b. This will be equal to 0. Is not it? What is this equation? It is a very well known equation. This is a quadratic equation. This is a quadratic equation. And it is also called characteristics equation. Remember, it is also called characteristic equation. It is also called auxiliary equation. Remember, it is also called auxiliary equation. So this quadratic equation is also called characteristic equation. This is also called auxiliary equation. How you can find out the roots of this equation, quadratic equation? Quadratic equation have two roots. Since here the value have taken lambda, so one root will be equal to lambda 1, let us say minus a plus a square minus 4b square root divided by 2. This is one root. Another root will be lambda 2, which is equal to minus a square minus 4b square root divided by 2. So you have two roots. Is not it? Two roots. One is your, suppose say lambda 1 is equal to this one. This is well known roots of the quadratic equation. Okay. So if you find out the value of the roots lambda 1 and lambda 2, you can easily find out the solution. You have two solutions. One will be y1, that is equal to e to the power lambda 1x. Another solution will be y2, that is equal to e to the power lambda 2x. So you have two solutions of the given differential equation. Okay. and we know if this factor, if a square minus 4b square root, this factor will be greater than 0, what will happen? Lambda 1 and lambda 2 are real. They are real constants. Is not it? But if a square minus 4b square root is equal to 0, then lambda 1 will be equal to lambda 2. That is, the roots are equal and only you have one solution. You cannot get two solutions. You have one solution. If lambda 1 will be equal to lambda 2, then you have one solution. And if a square minus 4b square root is less than 0, then what will be lambda 1 and lambda 2? Lambda 1 and lambda 2, they are complex conjugate, remember. They are complex conjugate. What do you mean by complex conjugate? Suppose e to the power ix and e to the power minus ix. They are complex conjugate. If one is plus, another one will be minus. They will be so lambda 1 and lambda 2, they are complex conjugate. So you have to remember this. Okay. So if you have a second order linear homogeneous differential equation with constant values, some constant values or constant coefficients, then you can find out the solution of the equation like this. You have two solutions. One is e to the power lambda 1 x, another e to the power lambda 2 x. And in this way, you can find out the solution of the second order linear differential equation in different cases in physics, that is mechanical vibration or electrical vibration. These formulas are very useful. Okay, so we will discuss more about this second order differential equation or more problems in the next video. Thank you.